Hi, everyone. Yeah, thanks. It's a pleasure to be there, and thanks to Winky and his team for this kind of opportunity. So, yeah, I'm going to discuss about harnessing IoT and machine learning in facility optimization. And at first, maybe most of you know GreenMesh by our product VGLX. So we do cloud IoT platform in the small country Slovenia. So when you visit our country, you may notice two things. The first one, somehow the Switzerland get the access to the seaside. And the second thing, that we have quite good coverage of the Things network. And when I was deciding which topic should I discuss here, I'm thinking about what all of these industries can be summarized, and they have the common important thing. These all are facilities, and in all of these industries, we should monitor the electricity, different assets monitoring, and other, let's say, objects. And what we're doing now is just collect data from many sensors. We collect billions of data points, and we just visualize data and maybe control the temperature control the heating systems depending on the temperature. And I want to argue to move from the model of measure and action to the predict and action. And I will convince that it's more effective rather than current applications. So, for example, now for the space utilization optimization for the occupancy detection and adjusting the heating and cooling, we use sensors, we use rule engines, but if we apply different machine learning algorithms, we can be more efficient and perform some prediction occupancy, which can lead us to schedule the cleaning cycles, which could be optimized as well. And based on the occupancy footprint, we can schedule the maintenance, and also we can forecast the indoor air quality based on the previous metrics from the footprint and temperature, humidity, and CO2 as well. In terms of power consumption, we can now, based on the collected data, past data, we can generate reports and invoices for the past consumptions. We can also detect some peaks, some generate shutdown alerts. But with application of the machine learning, we can also forecast future expenses depending on the past data, and also we can apply different algorithms to detect anomalies, not just peaks, but detect the anomalies patterns, which help us to identify the broken facility, for example. And this is one of slides which I like to generalize. We have huge amount of objects which we can apply the level sensors. It's towel, water dispensers, waste bins, and even the soil moisture sensors also have the same pattern of increasing or decreasing measurements. So, and using just single machine learning algorithm, we can apply this only single algorithm on all of these objects and not reinvent the bicycle each time. So unified platform can apply, it could be used in the agriculture, in the office, in the groceries, etc. And here is actually a live example. We get the large annual data set of the power consumption of the commercial and residential hourly load profiles. And we built quite simple algorithm which could predict the actual power consumption depending on the day or time. And we use only the power consumption data. But if we get the access, and we already have it, to the different data like outdoor temperature, and other weather parameters, and the people data from the people counters, we can get more effective results, more impressive results here. And since as more data as we can collect, we also can make predictions not only weekly or monthly time slots. We also can make the predictions on the daily and hourly basis as well. And many of yours may ask why I'm discussing about this, since there is quite a lot of applications which are already applied the machine learning algorithms. But from our experience, from our research, there is about 600 platforms and many thousand devices, which most of them just collect and visualize data. And the very small part of it serve some specific verticals. But there is also disadvantages that they have with they work with a small amount of devices, or serve just one single vertical. And we want to convince the audience that this is more important to build the solutions, build the versatile algorithms which could be applied in different verticals, and use as more data and sensors as you can. And moreover, you should deal with the old equipment, because we know before the IoT era, the ancient technologies also use the internet and collect the data. And since we have the access to them as well, it's more effective than convince your customer to switch immediately to the LoRaWAN devices or other technology. And you can as well use this data in combination with the new equipment to build more efficient predictive models. So as was mentioned before, use as more data as you can. For example, the weather data is already accessible. You can just input the geo coordinates and get the instantly information about the year weather in your specific location. And yeah, the successful pipeline of the harnessing IoT and machine learning, it's to connect everything, and you should be simple for the B2B, you should be versatile, and also you should be user-friendly, because the end customer needs to solve the business issues and not just deep dive into the what is the IoT or other technology. And this all information is inavailable if you cannot convert it into some benefits for the business. And based on the research, based on the real measurements, we can say that the energy savings by the applying IoT and machine learning can saving up to 30% in energy, and reduce maintenance up to 40% as well. So thanks for your attention.